Parametric splines are widely known for their flexibility and are commonly used in fields like computer-aided design, animation, and geometric modeling. Bezier curves, B-splines, and NURBS are all examples of parametric splines, valued for their smoothness, local control, and adaptability in shaping complex curves. However, despite their strengths, they are not commonly applied in curve fitting and data analysis, domains where these properties can be especially useful for modeling complex mathematical or empirical relationships. One reason for this is the complexity involved in using parametric splines to represent relationships in the typical y equals f of x form. Since parametric splines define both x of t and y of t in terms of a shared parameter, evaluating or using them directly in analysis or code can be challenging. SplineCloud overcomes this barrier by providing client libraries for Python and MATLAB, which handle the parameterization under the hood and allow you to use parametric splines in your code just like any regular function. This capability, combined with SplineCloud's advanced fine-tuning mode, equips you to handle even the most challenging fitting scenarios. When automatic fitting options aren't enough, you can switch to fine-tuning mode and adjust the curve manually to get the best result without losing smoothness. So, let's explore the advanced capabilities of the fine-tuning mode. To enter this mode, click on the Fine-Tune button on the Curves toolbox. Now you can see and modify control points of the curve and its knot vector. By dragging the control points, you can influence the shape of the curve. You can add new control points by double-clicking on the control polygon. To remove a control point, right-click on it and select Remove from the context menu. You can also add weight to some control points, which will force the curve to stick closer to these control points. However, beware that by adding weights to control points, you transform the B-spline into a non-uniform, rational B-spline, which you have to consider when reusing the curve in code. In some cases, you may wish to snap control points to data points. This can be especially helpful when you try to match the start and end points of the spline to data points. To enable snapping, click on the toggle with the magnet symbol at the top right corner above the widget. Well, there are more things to know about splines to use the advanced options of the fine-tuning mode. A knot vector is a sequence of parameter values that determines where and how the segments of the spline join. SplineCloud allows you to interactively modify the knot vector, enabling precise control over the local flexibility and smoothness of the curve. The position of the knots influences adjacent regions, so you have to get used to the response when dragging knots. By changing knot positions, you can efficiently eliminate underfitted regions without increasing spline order or adding new control points. You can add new knots by double-clicking on the parameter axis, and you can also remove knots by selecting the Remove Knot item from the context menu. Beware that there is a strict relation between the number of knots and the number of control points of B-splines. So, new knots are added automatically when you add control points and vice versa. By adding repetitive knots, you reduce the continuity of the spline segments. This can be helpful in situations when data has a steep change in the main law. So, instead of representing a relation with several functions and defining boundary conditions, you can still use a single spline with a break of continuity. Usually, automatic fitting algorithms produce non-uniform knot vectors, which reduces intuitive response on changing the position of control points. This can be fixed by checking the box Uniform Knots on the Curves toolbox. Here, you can also use the LSQ Fit button to automatically fit the position of control points using the least squares method. Once you are done editing the spline shape, click the Done button. Now, when you have updated the curve, all you have to do is reload it in your code. If you want to know more about the SplineCloud API and how to reuse curves in your code, watch a previous video in this series. In case you wish to undo changes you made in the fine-tune mode and want to revert back to the automatic fitting method, click the reset button. This is an irreversible operation, so all your fine-tuning will be lost. If you are hesitating, add another curve, apply automatic fitting, and compare the results. You can turn off and on the curve display by clicking on the I button on the Spline tab. Here, you can also change the curve appearance, color, and line style. Well, basically, this is all you have to know about the fine-tuning mode. I truly believe it can help you in achieving the best possible fit for your data, regardless of its complexity. Leave feedback in the comments and subscribe to the SplineCloud channel to be updated.